It takes a minimum of 3 days for a spacecraft to travel from Earth to the Moon. And it takes a minimum of 7 months to reach Mars. It takes 14 to 17 years to reach Uranus, the 7th planet in our solar system. It takes at least 80,000 years from Earth to reach Proxima Centauri. This Proxima Centauri is the closest star to the Sun, and it takes a minimum of 80,000 years to reach there using the fastest spacecraft with our advanced technology discovered so far. This means a person cannot travel that far in his lifetime. Let's say if a person can travel at a light speed of 3 lakh kilometers per second, it would still take more than 4 years to reach that star. But according to special relativity, any object having mass in this universe cannot travel at light speed. So traveling at a light speed is practically impossible. In fact, not only practically, but also theoretically, it is impossible to travel at light speed.
I guess most of you know what is a light year. And if you don't know, here's the explanation. The light travels at a speed of 300,000 kilometers per second. That is really very fast. Such is how far light travels in 1 year. That distance is called a light year. Technically speaking, 1 light year in kilometers is approximately 9,46,000 crore kilometers. So whenever I say light year, imagine this distance.
All right, now the question is, can we travel to a millions of light years distance? If not, then is there a way or shortcut to achieve this? In this video, let's learn if there is any other way to cover the million light years distance. And the answer is yes. There is another way to reach this universe to a distance of millions of light years. Since we cannot increase the speed, we have to reduce the distance. The only option we have for this is wormholes. We all know about black holes, but very few people know about wormholes. So what is wormholes? Are they really in this universe? If you enter a wormhole, can you come out? Is it possible to time travel through wormholes? Let's find out many secrets about wormholes in this video. So watch this video till the end. To know what wormholes are, first you need to know about black holes. I have already made a video on this. The link is in the description, but let me briefly explain you what is a black hole. When big stars in this universe die, they turn into black holes. These black holes have a very high gravitational force. Any object in these black holes, whether it is a star or whether it's a planet, gets stuck into these black holes. In the end, even light cannot escape from these black holes. All right, now let's go more deep into the subject to understand wormholes. This includes few physics principles, so please pay attention. According to Einstein's theory, this universe is like a rubber sheet of space-time. It stretches, it bends, it spins, and it rotates. In this flat space-time fabric, due to the presence of heavy materials like planets and stars, the space-time will bend, which means a curve is formed for it. The more mass and density for the object, the more that curve will be. In the center of these black holes, there is a singularity with an infinite density. But since the black hole has an infinite mass and density, it forms a tube there and ends with a singularity. Now, the interesting thing is, if there is another black hole with a singularity somewhere else in space, and these two black holes do not end with a singularity but are connected as a tunnel, then that's a wormhole. Einstein and a scientist named Einstein-Rosen in the year 1935 has published the paper with the theory of wormholes. In this, they mathematically proved that there is a possibility of a tunnel that connects two different places in spacetime. They developed the wormhole concept with the name Einstein-Rosen bridge, or bridge. They compared the wormhole tunnel with a bridge-like structure. To put it simple, it is a shortcut in space. Through this wormhole, a distance of millions of light years in the universe can be reached in seconds or minutes. Let's see that with a small example. If this universe is a two-dimensional flat sheet, let's say there are 2 points A and B in it. To reach from A to B, we have to travel all this distance. It will take some time, but if we fold the same sheet and make a hole, now we can reach from A to B very easily. There's no need to travel so far, right? The same is true for this universe. This 2D example is just to make you understand. But this universe is in 4 dimensions, so since the distance here is very small, it is possible to travel at a higher speed than light. All right, now to enter into a wormhole, there should be an entry and an exit, right? We learned about black holes in the beginning, right? Because of its gravity, it pulls in everything that comes close to it. This black hole is the entry to enter the wormhole. So we all now know about black holes. But have you ever heard about white holes? How does a black hole pull in everything? This white hole forces everything in it and throws out very quickly. So again, to put it simple, the structure in the tunnel that connects the black hole and the white hole is called a wormhole. Also, it is not necessary for all the black holes to have wormhole. If there is only a black hole alone, then anything that enters into it will not return. But if it is a wormhole, everything that enters it will come out of the universe through the white hole. This wormhole can connect some billions of light years away in this universe. Or it can also connect small distances away, like in meters or kilometers. Not only that, according to scientists, this wormhole can surprisingly connect from one galaxy to another galaxy, or from this universe to another universe in parallel. This means if multiverse is real, the traveling to another universe is possible with wormholes. It can also take you from one moment in time to another. So scientists say that time travel is possible through this wormhole. But as shown in movies, time travel through wormholes is not that simple. Due to some characteristics of this wormhole, time travel through wormholes is also not that easy. Wormholes are unpredictable. That is, if we enter a wormhole, we do not know where we will come out. As we said earlier, we can go to another galaxy or even to another universe, so we do know the destination. Some wormholes are unstable. That is, they collapse within seconds. So if we go to another place through a wormhole, it is not possible to come back through the same wormhole. And some wormholes disappears in seconds. And hence, as shown in movies, the journey through wormholes may not be so easy. In fact, the journey through wormholes is like a one-way ticket, and we may not like the destination. But figuring out the mysteries and learning the new things are what makes us exciting. Next, wormhole size. There may be many wormholes in this universe, but all of them are in microscopic levels. This wormhole size may be around 10 to the power of minus 33 centimeters. But as the universe expands, some wormhole sizes may increase. Next, as wormholes have more gravitational force, they come close to the walls and the wormhole closes. To prevent it from closing, there is an exotic matter surrounding the wormholes. Opposite to the regular matter, it contains negative energy or negative mass. For example, when an object weighs, it shows 1 kilogram. But this exotic matter weighs in negatives, that is, in minus kilograms. Without this exotic matter like wormholes, this wormhole closes immediately. All of these are obstacles to travel through wormholes. And moreover, we never witnessed any wormhole till now, except for mathematically proving on paper. We have not physically recognized these wormholes. Since black holes and wormholes are the same, it is difficult to recognize the difference between the two. Similarly, some wormholes disappear within seconds, so it is not easy to recognize them. Scientists say that even if there are wormholes, there is a greater chance that they will be in the middle of galaxies. And to travel in time, even if we travel at light speed for those wormholes, it will take at least 25,000 years to reach the center of our Milky Way galaxy. It is very difficult to reach the wormholes that are so far away. That's why scientists are trying to artificially create wormholes. But this is not as easy as we think. There is an issue in creating artificial wormholes. Since wormholes have more gravity in the center, any mass or energy in it, or even a light photon at the end, will collapse as soon as it enters. That is, it will be closed. To keep those walls opened, we need an exotic matter with a negative mass. But what is this exotic matter? Scientists have no idea how to create it. So scientists took a step forward in creating wormholes. That is, by using Google's Sycamore quantum computer, scientists have already started creating quantum wormholes in the lab. These quantum computers work on quantum entanglement. They create 2 simulated black holes and send information in the form of qubits. All that information reaches from one side to the other. So what scientists have created is a very basic simulation. It is not possible to create real wormholes now. Finally, so far, except for the existence of wormholes on paper, no real wormholes have been found. Not only that, Stephen Hawking also said that there's a possibility of wormholes. Likewise, the theory that black holes may exist is also proven on paper first. And after decades, for the first time ever in the year 2019, scientists took a photo of a real black hole in a galaxy called M87. In the same way, we should see if these wormholes will also be found in the future. All right, friends, to watch more such interesting videos, subscribe to the Let's Learn Together channel and activate the bell button next to it. Thank you for watching.